Sum or difference of cubes. Let me write that up here. That's the next factoring technique we have. So the fact that it's the sum or the difference means that now we can be added or subtracted. For difference of squares, we could only be subtracted. So I'm going to give you an example of this, and then we're going to go talk about sum or difference of cubes for quite a while before we try to factor this one. But here, this would be an example of the difference of two cubes. X cubed is obviously a cubed because x is being raised to the third power. Minus 8. 8 is also a cube number because it's equal to 2 cubed. It's 2 times 2 times 2. So one key to knowing when you have the sum or difference of cubes is being able to recognize when you see a cube number, like being able to recognize the 8 as a cube number would be important on this problem. So maybe one place we can start is to go over here to the side and just list some common cube numbers. So I'm going to list several here, and then others we'll look at how to check to see if they're a cube number. 1 is a cube number because it's 1 times 1 times 1, or 1 cubed. 8 is a cube number. It's 2 times 2 times 2, or 2 cubed. 27 is 3 cubed. 64 is 4 cubed. 125 is 5 cubed. 216 is 6 cubed. And the next one after that I'd suggest you knowing is 1,000, which is 10 cubed. So there are 7 common cube numbers that we see. Now, if it's not one of those, and you're wondering, is this a cube number or not, what you can do is cube root the number on your calculator and see if you get a whole number. Okay, for example, take 729. You see that in a problem, you're wondering, well, gosh, is that a cube number or not? Well, cube root it on your calculator. So you're looking for a function that looks like that. Hold your calculator up to me, Donna. Okay, I'll be back there in a moment. Let me show you where it's at on mine. You know, if it's in the list, you can recognize it. If it's not, you can use the cube root button to see if it's going to be a cube number or not. Okay, now, if you do have the sum or difference of cubes, then we're going to factor by using the following formulas. And they kind of look long and convoluted, but they're not as bad as they seem once we figure out how to use them. Here's the formula for the sum of two cubes. If you have a cube number plus a cube number, then it's going to factor A plus B times the quantity A squared minus AB plus B squared. If you have the difference of two squares, that would mean we're subtracted instead of added. Then the formula goes a minus b a squared plus ab plus b squared. Now, at first glance, those formulas look different, but upon closer observation, they're really the same thing. Let me show you what I mean. Look at this one. We got a plus here in the middle. Oops. Plus here in the middle. And then over here in the first parentheses, we got the same sign, plus in the middle. And in the second parentheses, we changed. We got minus in the middle. That pattern holds down here, see? We got minus here, minus in the middle on the first one. It changes on the second one. So one way to think of it is the sign stays the same in the first parentheses in the middle, and it changes in the second one in the middle. Okay. So, how are we going to approach a problem like x cubed minus 8 then? Well, we're going to approach it like any other one first. We're going to ask if there's a common factor. And on this problem, there's not. Now, here's the key to the whole thing, what I'm getting ready to say, this next sentence. If you have a sum or difference of cubes problems, my suggestion is first write it as something cubed and something cubed. X cubed is already something cubed, but let's write that 8 as something cubed. Well, what would I cube to get 8? I would cube 2. So I'm going to write it as x cubed minus 2 cubed. The reason that I want to do that is I can easily recognize what my a and my b are going to be now. My a is x, and my b is 2. A and b are going to be the two things that are cubed. If we look back up here into our formulas, we only need 5 things. A, b, a squared, ab, and b squared. And that's true whether it's the sum or the difference of cubes. So I've already got the a and the b, so the only other things I need are a squared, ab, and b squared. Well, since we've already recognized what a and b are, then those 3 things are easy to figure. A squared is going to be x times x, or x squared. AB is going to be a times b, which is x times 2, or 2x. B squared is going to be b times b, or 2 times 2, or 4. Now that I've got these 5 values, all I have to do is substitute them into this formula. So let's do that. So what's it equal to? A minus b is going to be x minus 2. What happened there? I'm not sure what happened there. Okay. And a squared plus ab plus b squared is going to be x squared plus 2x plus 4. And that is my answer. So to wrap up there, what we just did, something squared and something squared first. Then figure out what a squared, ab, and b squared are. Plop them in the formula. That's it. Okay, so let's practice a little bit more just to make sure that we're following along with what happened there. So the next one, let's do 27x cubed plus 64y cubed. So if this was my test, here's the way I would want to think. Okay, first ask, is there a common factor? And here, there is not. The only factors of 27 are 1, 3, 9, and 27. None of those go into 64. Since it's got two terms, the first question I would ask myself is this the difference of squares? And it's not. First of all, it's not a difference. And second of all, things are being cubed, not squared, and 27 is not a square number either. So it's not that. Then I'm going to ask, is it the sum or difference of cubes? And the answer to that is yes. 27 is the cube number for 3. 64 is the cube number for 4. So what do we say? We want to write something cubed and something cubed first. So class, what would I cube to get 27x cubed? 3x. And what would I cube to get 64y cubed? 4y. Okay, we've now got a, it's 3x. We've now got b, it's 4y. The only other things we need are a squared, ab, and b squared. A squared would be 3x times 3x, or 9x squared. Why don't you tell me what AB is going to end up being? It will be 12xy. It'll be 3x times 4y. That's right. And b squared will be 4y times 4y, or 16y squared. Okay, we're going to take those 5 values and throw them into our formula for the sum of two cubes. And that formula says a plus b times a squared minus ab plus b squared. La da 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 da. And I'll put a couple different color on there so you can see it on the screen a little easier. That looks pretty good. Looks like a lemon lime snow cone. And that is the idea behind the sum or difference of cubes. We have now looked at all the different methods of factoring that we're going to study. Factor out a common factor, grouping, AC method with shortcut, difference of squares, and sum or difference of cubes. Okay, in the next section, we're going to throw all those into a big pile, and we're going to have to pick out the appropriate factoring method to get our polynomial factored. Here is some practice on sum or difference of cubes. So this is still off of 6-3, so you're going to tack it on to the assignment you had last time. It's on page 337. I had you for a pretty good number of those. They're really not that bad, but maybe I could just do odd. So let's go 37 through 51 odd.